All right, so now we move on to balancing chemical equations. We hopefully know how to write them, and obviously there's lots of practice to that, and I'm going to have some practice at the end of this this unit and give you some extra steps in terms of reviewing that. But to balance, the reason we balance chemical equations is because of the law of conservation. The law of conservation says that the number of each atom must be the same on the reactant and the product side. That's not what the law is. The law says obviously matter can neither be created nor destroyed. So that means if you have 3 oxygens on one side, the reactant side let's say, you must have 3 oxygens on the product side. You can't have 2, all right? So if you have 17 hydrogens on the reactant side, you must have 17 on the product side as well. The law of conservation of matter says that matter can neither be created nor destroyed. And so here I am just kind of taking a little poetic license and saying the number of each atom must be the same on the reactant and product side. Okay, so obviously that's that. Now, how do you balance equations? Well, I like to find my little tips here and as going through, but you count the number of atoms of each atom per side. So the number of oxygens, boom, count how many you have on the reactant side, count how many you have on the product. The number of hydrogens, boom, count them on the reactant, count them on the product, etc., etc. You cannot change the subscripts, okay? You cannot change the subscripts when you are balancing equations. What you do is you use coefficients, okay? So you use coefficients to balance chemical equations. Let's look at an example here, and really simple example. Let's say we have hydrogen reacting with oxygen. This is one that I had earlier, to produce water. Okay, hydrogen reacts with oxygen to produce water. And again, that's the formula equation. Notice that hydrogen is diatomic, so I have the H2. Oxygen is diatomic, so I have the O2. And then water, I wrote the correct formula. I didn't write H2O2. Okay? Basically what we have here, and let's see if I can, hydrogen, if we look at our balls and sticks, hydrogen is yellow. So there's hydrogen. Oxygen is red, so oxygen actually has a double bond between, and there we are. And now water would be like this, with 2 hydrogens off of it. Okay? So now as we look at this, we say, well, we're not following the law of conservation, because if let me just put a little line here between my reactants and my products. But basically, I have 2 yellow ones, 2 hydrogens, and I have 2 oxygens on the reactant side. But notice on the product side, I have 2 yellow ones, 2 hydrogens, but I only have 1 oxygen. This can't happen. You can't lose an oxygen atom. So this equation is not balanced. Now, obviously, I've drawn them out with this little yellow and red balls and sticks, but you can obviously just count the subscripts. You've got 2 hydrogens, 2 hydrogens, 2 oxygens, but only 1 oxygen. So again, we're not following the law of conservation. Now I cannot change the subscripts, okay? I cannot write a 2 down here for my oxygen. Yes, that would balance my hydrogens and oxygen, but it changes what that substance is. H2O is water, delicious, love to drink it, quenches your thirst. H2O2, not so much. H2O2 is hydrogen peroxide. And I don't know that anyone, at least I don't go to the medicine cabinet when I'm thirsty and need a drink and down a bottle of hydrogen peroxide. It's not going to be too good, probably would make you vomit. You know that hydrogen peroxide is that stuff you put on cuts and it bubbles and fizzes and whatnot. Not something that you really want to ingest, okay? You may have used it to gargle before if you have, cold sores or canker sores, or if you've had your wisdom teeth out, but certainly not to drink it. So by writing or changing the subscript here, I've changed what my substance is. You cannot do that, okay? So that's not how you balance the equation. How you balance the equation is you use coefficients. And so a coefficient in front of the equation, in front of the formula, is how you balance them. Now, I have 2 hydrogens on the reactant side, and I have 2 on the product. I'm all set with that. I've counted it. If I have 2 oxygens on the reactant side and only 1 oxygen here, what I need to do is put 2 in front of it. Now it goes in front of the entire formula, in front of the H2O2. We would not put it between. And that basically says I have 2 H2O molecules. So again, basically it'd be like saying I have another water molecule. Notice there we are. Now I've drawn my 2. So notice I now have 2 oxygens. This 2 distributes to the H2 and the O2. So notice I have 2 oxygens. It also have changed, and notice I now have 4 hydrogens, okay, because it distributes to both. So I would have to come back to my reactant side and put 2 in front so that that distributes as well. Okay, so again, what I would now have is 2 molecules of hydrogen. And when you count them all up, notice I have 4 yellow balls, 4 yellow balls here, and 2 red balls, and 2 red balls there. So my hydrogen and oxygens are balanced. That's how you use coefficients to balance a chemical equation.